Assalamualaikum and welcome back. For our next example, let's solve question 20 from tutorial 9, where here we are asked to integrate Z over solid G, and G is the solid bounded but below by the cone and above by the sphere x squared plus y squared plus z squared equals 2z. Okay, so if you look at the equation of the sphere, you can see that this is a sphere where the center is not at the origin. Okay, let's rewrite the equation of the sphere using spherical coordinates. Okay, on the left hand side we have x squared plus y squared plus z squared. We know that that is equivalent to rho squared. And on the right we have 2z, and z in spherical is rho cos v. Simplify this by dividing both sides with rho. We get rho is 2 cos v. So another name for our sphere is rho cos v. Okay, now if you can't tell where the center of the sphere is, we can always do completing the square. Okay, let's perform completing the square on the equation. So here we rewrite the equation as such. Okay, now the coefficient of z is -2. So if we divide -2 with 2, we get -1. Okay, expand z minus 1 squared, we get z squared, which is there. And then we have minus 2z, which is the second part here. But then we have plus 1. So we don't have that originally, so we have to take away 1 so that we still have the same equation. Okay, all right. Now, rewriting this, we get x squared plus y squared plus z minus 1 squared equals 1. So you can see that this is a sphere of radius 1, but the center of the sphere is at 0, 0, 1. Okay, let's sketch our sphere. Okay, so here we have the y coordinate and y-axis, sorry, z-axis, y-axis, and z-axis. Right, so here we have y-axis, x-axis, z-axis. Okay, let's sketch our sphere here. The radius of the sphere is 0, 0, 1. Sorry, the radius is 1. The center is at 0, 0, 1. So let's say that's a 1 and that's a 2. So it will go through this point here and 1, 2, 3. So we'll go through that point as well. Let's sketch this. Let me use another color, green. So we have this sphere. It will go through point 0, 0, 2 and also at the origin. Okay, so another name for this sphere apart from that is this. So it's rho equals 2 cos v. Okay, now let's look at our second boundary, which is this. It's a cone. So from the previous example, you know that this is a cone that goes right in the middle, the 45 degrees angle. Remember that? Okay, so here we have a cone. So it will go through this point because it's 45 degrees. Okay, and it will go through this point as well. Okay, you can draw larger than that, or you can stop there, like. So I'm gonna erase the bit because it says our solid G is bounded below by the cone and above by the sphere. So I'm gonna erase the part that is not part of the solid. So this is not part of the solid. This is not part of the solid. This is not part of the solid either. So this is our solid G. Right. Let me draw that axis. Okay, here we go. So this is a 1, and here that's -1. This bit here is 1. This bit is also -1. Okay, all right. So here we are asked to evaluate to integrate z over solid G. Okay, we're not calculating volume here. Okay, if it's volume, then z is 1. Okay, all right. So first of all, we're gonna replace that z using spherical. So z in spherical is rho cos phi, and dv in spherical is rho squared sine phi d rho d phi d theta. Okay, now we need to get the limits for rho, phi, and theta. Let's simplify this. So here we have rho q cos phi sine phi d rho d phi d theta. Okay, let's get the limits for rho, phi, and theta. Okay, the first one is for rho. Okay, refer to our solid G. All right. To measure rho, remember we measure rho from the origin, and then we just draw a straight line across our solid. You can see that it starts at the origin. You can draw it here too if you like. It starts at the origin and then it stops on the green sphere. And the green sphere is governed by this equation. So rho, the limits for rho is going to be from 0 to 2 cos phi. Okay, now let's get the limits for phi. Okay, so remember how we measure phi? We measure phi from the positive z-axis. Okay, let's say you start there, and then you can see that it stops on the blue cone. Okay, or you can go from here to there as well. And the blue cone is represented by this, but remember from before, this is really from the first example, that is rho phi equals pi over 4 because the angle is 45 degrees or pi over 4. Okay, so phi is going to be from 0 to pi over 4. Okay, now let's get the limits for theta. So for theta, you just project your solid G onto the xy plane and you can see that it's a circle. Okay, and for a circle, the whole circle, the angle would be for theta is going to be from 0 to 2 pi because it's the whole circle. Okay, all right, now let's evaluate. Okay, the first one, the inner integration is with respect to rho. Okay, with respect to rho. So here we consider cos phi and sine phi here as constant. So integrate rho cube, we get rho to the power 4 over 4, and then replace rho with upper and lower limits. We still have d phi, d theta. Okay, replacing rho with upper limit 2 cos phi, we get 16 cos to the power 4 over 4. Okay, so here we have 0 to 2 pi, 0 to pi over 2. So 16 over 4 is 4. Okay, so we have 4 cos to the power 4, but then we multiply with cos there, so cos to the power 5 phi sine phi. It's ugly. Okay, hang on. Cos phi sine phi, and then minus 0, so we get this. Okay, all right, next is we're gonna integrate with respect to phi. So now we're gonna use our substitution method. Let's say you let u as cos phi, so du is going to be negative sine phi d phi. Okay, right, so here we have 0 to 2 pi, 0, and here we have 4. We can put 4 before. Okay, never mind, 4 here. So here you have u to the power 5, and then sine phi d phi is negative du, and we still have d theta. Okay, all right, now instead of changing u back to cos phi, we can always use limits for phi for limits of u. Okay, all right, so here you can see that the upper limit for phi is pi over 4. So when phi is pi over 4, u is going to be cos pi over 4, which is going to be 1 over square root of 2. So that's the upper limit for u, and the lower limit for phi is 0. So cos 0 is 1, so u is 1. So the lower limit for u is 1. Okay, let's erase this because I need more room. All right, now integrate u to the power of 5. We get u, okay, let's put negative here, okay, so that we don't get confused. Okay, we have u to the power of 6 over 6, and excuse me, and here we have 0 to, 1 to 1 over square root of 2, and we still have d theta. Okay, so here we have negative 4. Replacing u with 1 over square root of 2, that would be, okay, here we have 1 over square root of 2 to the power of 6. This is really 1 over 2 a half, and here we have 6. This is really 1 over 2 cube, which is 1 over 8. Okay, so we have 1 over 8, 1 over 8 minus, and then replacing u with upper limit, which is 1. So here we have 1. Is that okay? I put 1 over 6 before the square there. Okay, let me erase this. All right, so those are all constants. Let's simplify our constant. Okay, here we have 1 over 8 minus 1. That would be negative 7 over 8. And here we have 1 over 6. And then we have negative 4 at the back. Oh, sorry, at the front. Okay, let me get that. 1 over 6 times 7 over 8. And then times, oh my goodness, I did not turn it on. Okay, 1 over 6 times 7 over 8 times 4. That would be 7 over 12. Okay, and then we have d theta, 0 to 2 pi. Okay, let me erase this. All right, now integrate d theta. We get theta. Last step there. So we have 7 over 12. Theta, 0 to 2 pi. So from here we get 7 pi over 6. So that is the answer for question number 20 from tutorial 8. Thank you.